Okay, that should be recording, and it is. Hello and welcome to the EEPROM 9. It's been a while since we've had a teardown video, a very long while. And from the title, this is quite an interesting one, because what we have here is a thermal imaging camera. Now this is a new way of I'm doing this because I've actually got the Microsoft webcam hooked up to a articulating lamp stand, a bit like the Pixar lamp, but it was a fluorescent lamp, it wasn't a traditional Pixar lamp. And you can see me scratch my nuts, so that's added fun. So, we'll switch him on, so you get to see how he works. Now, I have mentioned that I own a thermal imaging camera in videos. In fact, I technically own 3. I have this one. I have one I've built into a Raspberry Pi, which I don't know if I've made a video on, using the 4x16 thermal cell and then a Raspberry Pi camera and all that, and this works a treat. I brought this for another project years ago that I never ended up doing, so I just integrated it into this project pretty much. Here's a nice Raspberry Pi Zero, because this seems to be the perfect use for Raspberry Pi Zeros as a single-use computer you integrate into projects. Now I would love to show you like images I've taken on this, but I currently have still not managed to get a serial port for this thing, and I'm not sure if I can really show you it. Yeah, there we go. You can see my hand in thermal. It's out of focus because it's focused at the distance. Ex-fire department. Nice little unit, actually. But we'll switch him off. And we will start the teardown, because there's a lot of screws to remove out of this mofo. A lot. And we shall enjoy a good long catch-up in chatty goodness that we used to do back in the day. Of all this good jazz. Now, I don't have the ability to... Well, I do have the ability to zoom, like this. Whee! But then I have to readjust the camera. But, yeah. Our zoom is very traditional. It's very SLR-like when you're using a prime lens. Like I quite often zoom with my Fuji with my feet. So this is from about 2002, Argus 3, the image core, because these often are built off pre-built image cores, and then the companies like Argus and that integrate the image cores into their own hardware, is a Raytheon, built by Raytheon. So those of you who are in the thermal imaging lingo will know who they are. Those of you who aren't will not. I do not actually need to take this part off from memory, so I won't. These screws need to come out because there's actually 2 options. There's actually an option where you have hard carry handles. This one thankfully has the soft ones. I mean, I actually brought this camera over a year ago because it was, well, I had it when I was back with Aidan. He's another story for another video one day. The shenanigans that happened there, because it's kind of a bit of a tragic story, really. But yeah, this is the part where well, I'm recording, so I could potentially do some editing. I will see. But yeah, as you can tell, this is like one of those bazillion screw devices, you know. Any of you who are like me, who like taking shit apart, which is probably everyone watching this, will know. Now, I have actually taken this apart. If you're on my Facebook group, you've seen the photos. If you're on the EEV blog, you'll have seen the photos. And if you are... Are you the right size? You are too big, so I want you. I could swear I lost one of these moving. There we go. I had to drill these out when I originally tore this down because some of these screws actually did that classic screw fraying thing that they sometimes like to do where they disintegrate, so yeah, that was fun to deal with. Now, under here is a serial port. We shall show you that, although you'll see the backs of it when you're there. This bit is obviously the whatever funny material it's called. That's a serial port using a LEMO connector. I did order one for this, but it was the wrong size, which was really annoying. So I still have no way of hooking this up to a computer without like doing a whole new cable. This is the temperature sensor, because this is a BSD sensor, which is a previous technology to the what do they call the modern one? They call it the I forget, but yeah, that one just uses a single flip-on occasional calibration shutter. This one has a spinny wheel, just like the Vidicon ones do. And speaking about that, what about my third thermal imaging camera? Well, that's sitting at work under my desk because it's a Vidicon type. And you're probably guessing the fact that it's not here. Yeah, it don't work. And the reason it doesn't work is really annoying, because it's missing a very important unobtainium part. Can you guess what that part is? That's right, children. It's the Vidicon tube. And yes, before those of you come out the woodwork and start saying, technically it's not a Vidicon tube. I know, it's just the best way to describe it. I know it's... But to be honest, it is a Vidicon tube because it uses Vidicon tube tech. So they come off quite easily, and these are actually user removable. And then you have your standard warranty void seal, which we've already snipped off because do we give a shit about warranties? Nah, we don't. Now, we might even be firing up the scope, because we've got all the oscilloscopes and whatnot around me, to investigate and find a composite output I want to hack into, because I actually want to do some photography with this thing. You know, it'd be quite nice to get like shots of the London skyline and stuff with it. Oh god, it was funny when I used this down in the underground, because I think someone complained to the staff about me with this strange thing, because a member of underground staff just came up to me and was just like, seemed very nervous, and it's just like, what's that you got there? What are you doing with that? It's just like, it's a thermal imaging camera. It's like, why you got it? Is it like for some work thing? It's like, nah, just for fun. And it's like, can you refrain from me using that, please? It's like, fine. Which I found quite funny, because me being me, it's just like, yeah, thermal camera, of course I want to play with it. Thermal cameras are awesome. This is a standard resolution screen that's absolutely terrible in the sunlight. It's like you have to shade it. That's why the rubber, this is so critical. You stick your face up to it and cover it. It's just like, yeah. That's one of the things I also want to do, is potentially mount a better LCD in there. The only thing is you lose a lot of the funky functionality. So, yeah, I also want to add in a method of focusing it without compromising the waterproofness, because I love the fact this thing's fully waterproof. Yeah, you're going to be that one, aren't you? Yeah, that's fine. Yeah, here's where your big arse screws go, and you'll notice they're all threaded screws, because this thing's basically built like to sort of mil-spec quality. And it's nice to see a life-saving device that's actually built to really high quality, rather than it just be it depresses me that some of our most advanced technology just goes into military, which is just focused on, well, killing each other. I'd rather it go into things like this, which is used as a life-saving device. Because firemen would use this to see through the smoke to rescue people. So we've got a few screws which don't actually, they have an unusual threading, which is interesting because all the threads are the same, so I don't know what that's all about. So far I've come across two of those. So yeah, we're getting in. This is your external thermometer that will give you, because the screen will show you the different temperatures. It'll give you a spot, which is measured by that, ambient, which is measured by that, and your thermal view, which is here. So this side will just pull off easily now, so he can go down there on top of my drill box. There's not really much to see under here other than the composite output and a place where a radio antenna will go. And we've accidentally switched it on, which means we can actually show you what I was talking about, actually. But while it does that, I am going to get the other Allen key and start liberating screws. Because this thing does have a cow period before the thermal imaging comes back, because apparently there's a Peltier device between the sensor and its heatsink. I say apparently because it's not inherently obvious when you view in between the sensor, and to be honest, I'm not going to go ripping the whole lens mechanism and sensor apart. So if we zoom down on the, oh god, I shouldn't have done that. On the display, and the camera can focus for once in its life, we can see we have, oh yeah, thermal's back online. The ambient temperature, which is apparently 27, which is quite hot. Spot temperature, which is 32 because it's pointing at my hand. Date, time, scale, battery. There's also an IR input for a remote, which uses a universal remote type. This is a Philips one, so it uses whatever codes they got there. To give us that, hang on, let me just get the screws back up there, because that was not ideal. So yeah, I probably don't want to be adjusting the camera too much, because yeah, I'm putting the screws on the base and sort of just putting them in piles. So we'll turn him off. So most of it, so all the menus and that are accessed through the remote control. If you don't have the remote control, you can't actually change the settings. And it's got all different colour scales, abilities to view photos and all that. And it takes standard sort of video camera batteries. Now these do have a particular name, and this one's got a model number of VD153. But this is basically a very standard battery type that was used on video cameras in the 90s, especially the Sony ones. And some of you will remember this camera, but yeah, this one takes these batteries as well. The only thing is this video camera has decided to keel over and die while it's been in storage for whatever reason. Certainly the camera part will not fire up. I don't know why that is, so he's on the list of things to fix. That's not where the battery came from. The battery came with the camera. But the nice thing is my dad's old video camera was an old Sony that was older than that one, so I already had the charger because I was using it as a power supply for my ZX81 at the time. So we were looking to firing this up when we got it open. But yeah, it's pretty simple on use, and this also has wireless options, so this can do digital zoom in and activate the wireless, I think, if you hold it. But the wireless option is not fitted in this unit. And to be honest, wouldn't really be needed, because I could easily add in wireless video if I so wanted. I'd just use a mini FPV system used for RC quadcopters and that kind of stuff. We're 14 minutes in and we're yet to get inside. How fun. You can also see some of the other crap I've got dashed around the set, including the HP gain phase meter, which was subject of its own video many years ago now. God, it's hard to think that All that stuff to do with uni was many years ago now. Oh man, am I old? Maybe. Oh, this is fun. This screen's in the way. That's annoying. Whatever shall we do, mistress? Dobby the house elf. I don't know why I just randomly thought of Dobby the house elf, but hey. The Harry Potter fans go wild. Hang on. I might have a better way of doing this, actually. Thinking about it, you are... No. Yep, you are him. It would be nicer to do this with a proper screwdriver rather than these Allen key things. Which the Yanks call Allen wrenches. I'm not entirely sure why. I'm not entirely sure why little things like that have names depending on which side of the Atlantic you're on. It's a bit bizarre. They've just always been known as Allen keys in the UK. Not that they're actually keys. Allen wrench is probably a more accurate term, to be honest. So out come the screws as fast as I possibly can. I'll save you the whole putting it back together thing. If you take this off, you can just remove the screen module, which would probably be for ease of replacement and maintenance. Because this thing looks like it's designed to be, well, it's definitely designed to be rugged and robust. There's no way you'd accidentally break this through normal use. I mean, this thing's designed to survive being taken into fucking burning buildings, for God's sake, so... Yeah, although it does apparently have a certain maximum temperature range, but... Well, everything will eventually melt if you up the temperature enough. But yeah, from 2002... The previous version to this was the Argus 2. Yeah, I've been doing my research. I've been obsessed with thermal cameras for a long time, and I wanted one of these for a long time. And this has an astounding amount of random uses you wouldn't really expect until you own one of these. From walking the dog in the middle of the night to finding and detecting leaks, because it's very good at detecting damp in plaster and that. When my ex flooded the parents' house, I was able to monitor what was going on there to whether it was all drying out or whatnot, and it did dry out in the week while they were away, so yeah, he got away with that one. And we're almost at the last screw liberated, so if the entire audience hasn't buggered off, I don't know, to watch porn or whatever, we actually get a view of the electronics. Ah, there we go. We just want to be a bit careful because we got some fragile stuff in here. So this is our display. There's some silica gel jammed down in here, which is very common for these sorts of things. The back is purely the display. Now this is early 2000s capacitors, which basically are decent, so we don't need to worry. We've got Cfl Inverter. We've got parts of the inverter unit actually mounted to the circuit board. Going down to the actual tube that's in there, it looks like it's just a single tube. Sort of your standard chips that drive it. We've got a nice little board here with an interconnect which goes to the actual board with the FPGA, which I reckon is doing most of the smarts, and it's definitely doing all the user interface control stuff, clock, all that jazz. And we have, it's labelled, because I know you guys can't see it, the top is GND for the ground. We've got 5 volts, we've got tin, coal, brightness, COL, TIN, which is tin. Then we've got CNT and PIC, or PIC kit. Then of course the buttons, they actually go to the thing. They go to the actual circuit board, they don't go into the display. Now interestingly, there's this that goes into the display and this that actually go back to the control board. So yeah, this board is purely... I'm going to put this down to one side where I can easily get to it. This board is purely for the user interface, and it even has vid controller ARGUS 3. We got issue 2, and the date codes of these chips are, if I can find one with date code, 0325. Have we got another one? Just to confirm that, 0327. This will be the microprocessor, which has a number on it. We got not your CR32, we've got a CR2430, which is an unusual type of battery, but it still looks like a 3-volt lithium. I mean, we can actually measure that to see for certain, and I certainly see no reason why not to. I mean, it is working because it does hold the time, as you saw. The time, I think, is a little wrong on it, but the date's all good. So I should just be able to slip him down there. Let's see if we can... There he goes. I know that's you not having connection right there. Oh, Jesus. Ah, there we go. It's 309.55. I hope you can see that. If you can't, well, I will have to figure out lighting through other means, because at the moment I've just got the direct point source. So yeah, standard thing. There's your IR sensor here, standard remote IR. LED that indicates power, several oscillator crystals. You know, this looks like your pretty standard jelly bean processor board. Underneath you've got something that looks quite interesting. This is actually where the power board hooks up. So this is actually your power distribution, this one. So you got your LT1370, which I can tell you is most definitely a regulator, and it even has linear written on it, which is actually going to be the company, but that's going to be power regulation. There's something of a switch mode there. Inductor coil, all that good jazz. I don't see any obvious I2C chips. There's whatever this thing is, which looks like to be some kind of optical sensor. I have never noticed him before. He's new. I'm wondering if he's something to do with the battery, because he just sits out. Yeah, he will just spend his life staring at this bit of plastic, so I'm not entirely sure why there's an optical sensor there. Seems a bit random. Not entirely sure what that's about. That seems entirely right. Unless that's temperature. Could be temperature. It's very exposed though. That looks, yeah, that is weird. That has me intrigued. Oh, they're just big enough to remove the module. Just big enough. This is actually a CD-ROM spinner motor, which spins the spinny disc. Now that's good, because that's an easily replaceable part, and that is the sort of part that's prone to failure because, well, mechanical. Now there's actually 3 boards, and I think the one underneath is actually a processor board because it's got the most on it. But we've got these bastard Nintendo screws, and I don't actually have the screwdriver to undo them. I only have the ability to remove them destructively, so unfortunately we're limited on how far we can actually take this thing apart. Because, well, I want it to continue working. These things are expensive and not entirely that easy to get, because you often find yourself in bidding wars. I was lucky to get this for about 180 quid. Postage was about 20, so yeah, it was 200 quid. Not exactly cheap. Cheap in terms of the thermal cameras. because if you buy a brand new one for that, you get one of these shitty Seek Thermal or shitty FLIR things, which have a crappy resolution and have a god-awful frame rate, which is capped to 9 frames per second because of basically bullshit export laws. So that's a fun fact for you, that you're not allowed to export them to certain countries and all that jazz, but it's within a zone. It's like basically all like NATO and US and that. They can freely export all this kind of stuff as they want, from what I can see from the research. Now we pull out the really interesting bits. So I will pop the power off. Now, one thing to note here is it's not keyed. You could easily plug this in the wrong way round and just end everything. But we are not going to be that stupid, because thankfully the cables sort of retain their thing, and it's blue and purple at the top. So now we're getting to the interesting bits. I will start with the not so interesting bit of the internal of the cable, which is still quite heavy actually. There's actually a thread in the EV blog that I put a teardown of this to picture form that I will link in. So this is what I like to just call the I/O board, because this interfaces with all its external extremities. So we got the back end of the lens, and that's not actually a lens, it's just a window to protect the lens, because germanium lenses are incredibly fragile. We've got the back of the LEMO connector, which I don't have. Only uses 3 of the pins. Maybe I should just wire it in manually, but TX, RX, something called AMB. Oh, that's for something else. It's TX, RX, and ground that are the ones that are relevant to this. The other ones, these are for the ambient. Yeah, they're going to be for Mr. Temperature Sensor at this side. This is the thermal, and it's actually made by Raytech. So I think it's a Raytheon part. And these things are apparently really expensive, these single point sensor temperature devices. This is an actual plug-in module again, but it's keyed this time, so you can't plug it in the wrong way round. Here's your composite out that comes from the actual board, because that actually connects into interconnect down here. So we'll pop him back in. And we've got the battery compartment here, which is pretty bog standard, but the nice thing about this is it can fit these batteries both ways round, as long as it has all the right contacts installed, which this battery doesn't. So this is not a battery that came original to the unit. Now you can see where the RF unit would go for the video transmitter, and also where the antenna would go as well. And then there's something PA, which I'm guessing is linked to the RF transmitter, and a few other unpopulated ICs. And also a little fuse there next to a voltage regulator that looks like it's a 3.3 volt voltage regulator. Maybe a 5 volt actually. No, that's a 5 volt regulator. I read it wrong. So that's this side. It's basically I/O board, battery compartment and connector. Not the most exciting thing in the world. But this is where it gets interesting. Now, here's the board in the middle that I talk about having all the intelligence, brain and processing. And that is in the middle, and that actually connects right into this front board which holds the sensor. So this doesn't actually have all the processing on it. These are the Raytheon units basically. And I don't know if it's going to be branded anywhere, because I'm basically going off of what I've been told by other people who are knowledgeable on this sort of stuff with thermal cameras. This is issue 4. Now apparently you can get composite output through these, and this is unfiltered, doesn't have any of that OSD crap on it, which is perfect for like photography type applications, that gets outputted through here. So I'm thinking I ought to find what this is, the pinout, and output it through the RF port. Now here's our spinny shutter. Interestingly, it's made out of plastic, and it's not your like traditional spinner that you'd get on a Vidicon thermal camera. It's like cut down really thin PCB material, and then it's done in like a spirally sort of thing like that. It has this pattern, but only a solid PCB. So this will be the material they use for the burglar alarm lenses. I forget what it's called. It's a special type of plastic that's actually transparent to this thermal stuff. I think it's PTFE, and because that's oh, that was just magnets. Bags. You've got a number of temperature sensors which are mounted all over the case and all that jazz. Is that the no, that's not the Peltier device. This is actually the optical sensor here to see if this is spinning. So that's actually good. There's a little slit in there. I just seen it. There's a little slit, so every time it rotates it will see the slit. You got a little stepper motor drive which will operate the iris mechanism, which is very smooth to movement, and for whatever reason it is always in default in the open position when it's off, but apparently it's not a problem for these sensors. But there's not a lot on here other than FPGA, which is interesting, and then there's a board interconnect going to the power board. Surprise, surprise, bearing in mind this doesn't interconnect to it. So this also ends up being a bit of an interface board in itself. We've got another voltage regulator down here. That's a classic 7A M05. So that's something to keep an eye on, because after 30 years these things tend to fail. The sensor, which you can see a whole bunch of decoupling caps around. I'll try and move the light so it's more easily visible. In fact, actually, we might just run off the room's ambient light. Hang on, let me just position this. Camera, focus, focus, focus. There we go. We've got the nice little actual BST sensor there. And then, as you can see, it looks like a ceramic package. It's quite a big sensor, actually. It's got a really nice area, you know, especially when you consider photography in that. And the lens is like suitably sized to match it underneath. You can see more of the rolling shutter as well. And then easy points to dismantle it. And here is where you'd focus it. So I'd need to fashion some sort of motorized system here. This is what I mean. It's not exactly a simple task. Here's one of the temperature sensors I was talking about. There's a few of those dotted around in various random, sometimes quite secluded places. This also heat sinks all the way to the back here. Mod record, like it was in the MOD. The processor board, which will do all the smarts for the thermal imaging stuff, is here. This middle board, which we can't get out because of these evil Nintendo screws. It's not just Nintendo that uses these blasted things. It's also got a lot of its own power regulation on board, so there's going to be a lot of non-standard voltages. This is purely stepper motor drive and some auxiliary sensors by the looks of it. Yes, sensors for the to tell whether the shutter's open or closed, which you can see there. And that is really all I can show you from that. I don't know what this is all about. It's like a little optical sensor. Maybe it's another temperature sensor. I'm not going to poke it because it's actually completely exposed. Yeah. There's a fun bodge. It's even heat shrunk. I just noticed that. There's even some optocoupler isolation. So we'll pop him open. That's soldered in on the wonk. That's a bit how are you doing, especially for such a high quality, well manufactured device. This module itself isn't actually that heavy. It would be quite good to get a smaller one of these that I can mount to the front of my car so you can see ninja pedestrians in the dark. Now, one thing I do want to do, and I don't know how easy this is going to be, is figure out what the composite is. We can figure out what ground is, though. That's certainly easy enough. Oh, it's a bit echoey in here. So, what would be a good ground point? The chassis, of course. No. Ah, you. Oh, that's brilliant. These are both chassis. That means video can only be one thing. So I need to, at some point, get something that connects this to the chassis that outputs. I wish I had the connectors right now, because I'd do it now on camera, actually, because it's quite an interesting thing, actually. But that'd be a fun little modification. I'm looking round on my jumble side of a desk to see if I've got any connectors I could use, and I might have something in here. Because this is a whole hodgepodge of random bits and pieces in here. Oh yeah, I forgot about that CFL light I took apart. Oh wait, that was an old LED one, not CFL. LED died, but it wasn't actually the LED module. No, I do not have the necessary bits to do that. I dropped something then. What it was, I shall never know until my foot finds it in the middle of the night. When this room is dark, when I'm looking for something, probably. So yeah, we found the video pins. Ah, it was a spring. So yeah, that concludes my teardown of a thermal imaging camera, more specifically an ARGUS 3. Hopefully I got most of the points across, but yeah, I'm definitely going to be tapping into that and seeing what the output of that looks like, because apparently it's the raw output. Apparently it does hot black though, which is not usually how I like to have the thermal layout done, but beggars can't be choosers when you're bypassing the internal system. But yeah, that's all for now. Thanks for watching. I hope you enjoyed. I hope this was actually interesting. And I shall go before I ramble too much. And hopefully I got everything.